All right, so let's look at a couple conversions. I'm going to start off slow, and then we'll do a couple more complex ones, okay? So let's say that you have 25,500 grams of something, and you're like, that's a ridiculous way to measure it. I don't want to measure it like that. How would I convert that into kilograms? Well, what I tell you guys to do is to do a little stoichiometric table in which we do conversions. Okay, so start off with what you have here, set up a table like this, and then at the bottom, what goes here is always what you have here. Okay, so I know that grams has to go down here. And then I'm trying to get to kilograms. So if I know the orders of magnitude difference between these two, then I can put kilograms directly there. Sometimes you won't know it, and then you'll have to go to grams and then to wherever. But for now, I didn't make it too complex. Now, the question I ask you is this. Which of the two is greater? I promise you that word says greater. Is it grams or kilograms? Which is bigger?
Kilograms?
Yes, ma'am. So my trick for you is this. Okay. We'll use UTD orange here. Put a 1 in the larger unit of measure and never worry about decimals or 10 to the negative number. Okay, it's always going to be positive if you follow that rule. Okay, tell me kilograms is bigger. So what I'm going to do is I'm going to put a 1 here. And then I need to know the order of magnitude difference between these two. Which one's, what's the difference? 10 to what power?
10 to the third.
Very good. So now that I know that, I can divide these two, and that should take this decimal 1, 2, 3 places. And now we have a much more reasonable way of looking at it. Okay, so let's go a little bit more complex. Let's look at something like, let's go with 0.00000045 kilograms, and I want to go to milligrams. Okay. So in a conversion like this, if you know the direct link, you're good to go and you can do it in one step. If not, you're going to have to do 2 steps. So what do I say? Always start out with what you're given. We have 0.0000. Oh, that's it. A lot of zeros. Very good. This is good. I'm a little rusty on my accent, so I apologize. Here, what I tell you the rule was, what I put down here?
You put what's on top.
Very good. This is the kilograms, so that is what goes down here. And then, do y'all know the order of difference between kilograms and milligrams? Okay, so because you don't remember, what we're going to have to do is we're going to have to pit stop at grams, okay? And then after we get to grams, since we know the relationship from grams to everything, we can go from grams to milligrams, okay? So the rule that I told you, eso, it applies once again, okay? So which one of these is bigger? Is it grams or kilograms?
Kilograms.
So I put a Juan, ¿cómo estás? With kilograms. And then what is the order of magnitude? Well, that's the same as what we did before, 10 to the third. And then which one of these is bigger?
Grams.
Grams. So we put a 1 there. Don't have to worry about a negative exponent if I follow that rule. Okay? Are you with me? So this is 10 to the 6. So what I do is I move this over 6 places. 1, 2, 3, 4, 5, and 6. So that makes a lot more sense to just say 45 milligrams rather than saying this ridiculous number. Are you following me?
Yep.
Uh-oh, I'm going to need a restraining order. She's following me. My jokes are horrible, Lisa.
No, it's good.
I'm sorry. Don't hate me. But I will try to make you guys laugh here every now and then. All right, so here we have something a little bit more complex. Let's look at this. Let's go from, so on this one, I'm bringing this one up because I want you to remember that if your conversion or your units are squared, your conversions must also be squared. All right, so the overall process remains the same. You put what you have in the denominator, and then in the numerator, what you want. And what's the order of magnitude difference between the two of these?
10 to the 3
Good. Which one's bigger?
liters.
So you put a Juan there, 10 to the 3, and that's where most people would leave it. And they would get the answer wrong because it's squared. Okay? Because it's squared, your conversion also must be squared. Are you with me?
Mm-hmm.
Okay.
Yes.
So this is 10 to the first, this is 10 to the sixth. So when we do our like bases, what's the rule? What's this become?
10 to the negative 5.
Yes, ma'am. I like how you sang your answer there. 10 to the negative 5. All right. So any questions on conversions? They can get a little bit more funky, in which they, want you to take 25 miles per hour and convert it to centimeters per minute. But let's look at that one last problem. I'll do it for you just to give you an idea of what did I say? 25 miles per hour to centimeters per minute. I believe that's what I said, right? So what I do is I put m on top, and then per means on bottom. Okay. And what I do is I just work each one individually. So let's convert miles into feet. And then because I right now can only remember the conversion of centimeters, to inches, we're going to have to go to centimeters. But there's 1 feet to meters as well. I just don't remember it right now offhand. So feet to inches, and then inches to centimeter. That would give me, when I cancel everything, what I want, centimeters on top. Are you with me?
Mm-hmm.
Okay, so now we got to fill this in. You know how many feet are in a mile?
I don't
I
know.
don't like feet. They smell funny. I think it's 5,280, or is it 86? Oh, I think it's 80. It might be 6.
No, I
Alejandro,
think
can
it's
you check
80. I
that?
looked it up.
Oh, okay. I'm getting old. My brain's forgetting stuff. There's 12 inches in a foot, and then there's 2.54 centimeters in 1 inch. So then we can convert the time. We know that in 1 hour, okay, so put that in your calculator. My calculator is on my kitchen table downstairs. So somebody can tell me what that is. That would be much appreciated. And we can move on to the next topic. Okay, hopefully you can use a calculator by now. That's not what I'm interested in. The next thing we're going to talk about is uncertainty measurements, sig figs, the difference between accuracy and precision. Okay, so sig figs. What is this thing that you are calling sig figs? I do not understand. You guys okay with the accents and the silliness, or do you want me to be serious, guy?
No, I think it's good.
Sig. I can't spell. Oh no! What these are essentially a way for scientists to determine how accurate they're being in their calculations. And typically, there are times in which we use these sig figs when we're measuring to determine how exact we are being in our experiment. Okay, so what is a sig fig? How can I recognize it? Well, okay, so first rule for sig figs is anything that's non-zero is significant. Number 12 has two significant figures because both of those are non-zeros. Now, when we're talking about zeros, it gets tricky. There's a bunch of rules, okay? So the first zero rule is any zeros between two significant figures are significant. So in the number 101, how many significant do you see? Did I say 3? There's 3 sig figs. Do you guys see that? Because it's in the middle of two non-zero numbers. Yes or no?
Yes.
Yes.
Okay. Leading zeros to the left of the first non-zero digit are not significant. So in the number 0.00012, how many sig figs do you see?
Just 2.
Bless you. I know, that's a bad joke. 2 sig figs, that's absolutely correct. Trailing zeros. Let's talk about trailing zeros. Well, these after a decimal are significant because somebody took the time to go to the 10,000th place or whatever place they went to using some really precise instrument. So therefore they're significant. Otherwise you're discounting all the hard work, right, that this person did. So 2.50000 actually has, I shouldn't have put so many zeros, 1, 2, 3, 4, 5, 6, 7 significant figs, right? They took the time to measure it all the way to this spot. So don't do them a disservice and be like, yeah, it's 2.5. Okay. If there are no questions, I shall proceed to the next rule. If there is no decimal, trailing zeros are not significant. With no decimal, then it is not significant. Okay. So let's look at $1 million. I have $1 million to give you. How many sig figs do you see?
Would it be just 1? I'm not sure.
Yes, ma'am. Okay. So now what I do if I got to add or subtract or multiply or divide these things? Get you a calculator, buddy. Okay, so rules for addition of significant figures. Okay, so this is addition and subtraction. So I'm not sure why that's a comma there. You're just gonna erase you. Okay, Olive. So what you do is you look at the sig figs and you use count and your answer will have the smallest and what you do is you use your rounding rules. So let's look at an example. if I gave you 2.1, 3.25, 4.001, and I asked you to add them up, what you would do is you'd bring that down. That's 5, that's 3, 2 plus 3 plus 4, carry the 1, give you 9, right? And then since your smallest number to the right of the decimal is 1, you should only have one number here, okay? So what you do is you look at the number after it. If it's 5 or higher, you round this up. If it's 4 or less, you keep it the same, okay? So it'll be 9.4 in this case. Right, let's move on. Let's look for multiplication and division. Reglas para multiplicar y dividir. So what you do here is steps are going to be to count the significant figures of each number being multiplied or divided. Your answer will have the smallest number of significant figures. Let's do this. I'm just going to make up a problem, and I want you to tell me how many sig figs would you expect in the answer.
2 sig figs?
No.
No.
How many sig figs do you see in the first number?
Is it 3?
How about down here?
2?
2. How about up here?
Just 1.
Juan, my good friend Juan.
Oh.
So
Okay.
this one has 1 there. I see, said the letter after B. I know, it's horrible. Can anybody tell me the difference between accuracy versus precision?
I don't really know how to put it into words, but I can visualize it on like a target. So like
That's
precision
a good way to do it.
Precision would be more closer to the bullseye in the center, and accuracy would be, I think, how many other like arrows or shots hit a certain point.
Okay, so accuracy is how close you are to the actual value, right? How accurate is your measurement? Precision is the repeatability of your measurement, okay? So if you're shooting your arrow and your shots land like this, almost looks like a clown there, doesn't it? If your shots look like this, you're pretty accurate, okay? If your shots look like this, you're being very precise, but you're not being accurate because you're repeating everything and you're getting very similar results, right? But they're not actually close to the target. Okay?